Okay, and here we are at 11-6, our last section of the chapter, also our last section of the year. Segment relationships and circles. First thing I want you to notice is that we are talking about segments now. Last week we talked about angles and arcs, and they had rules like cutting in half and adding and subtracting. We're no longer going to be doing that. The rule changes because we're talking about something different now. We're talking about segments. So this first one says if two chords intersect in a circle, let's draw that. Two chords that intersect inside the circle. Here's one chord, here's another one. If two chords intersect in a circle, then the products, that means multiplication, we're going to multiply for this rule, then the products of the measures of the segments of the chords, these chords, are equal. Okay, what's happening here is that there are four segments. There is this segment right here. There's this segment right here. This segment. And this segment. There's four pieces. And this is so easy. If you just get what I'm saying right here, you'll find this part one of the easiest problems that you have to do. Call this piece M. Call this one N, the blue one's N. The green one can be Q, and the yellow one can be R. Okay, all you have to do is multiply the parts together, but the trick is to make sure that you use the two pieces that are on the same chord. So M gets multiplied by Q, and N gets multiplied by R, because together they make up the same chord there. It's kind of like cross multiplying. A lot of times you'll hear me just use the word crisscross because it's not exactly cross multiplication, but it's the same idea. You multiply M times Q, and that equals the other segment, N times R. Notice it doesn't mean that the two chords are congruent, but the product is congruent. N times Q is equal to N times R. And so the key word here is where they intersect inside. Segments that intersect inside. I have to distinguish that between the angles from last week. Inside segments. It means that you crisscross when you multiply. Crisscross, multiply. All right, crisscross, multiply. The next rule talks about if two secant segments are segments that go through the circle twice, drawn to a circle from an outside point. If you have that, then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant segment and its external segment. A lot of words. Let's break this one down. Two secant segments look like this. Goes through the circle twice, and it's not a secant line, it's a secant segment. And you need to have another one that they're secant from the same external point. Okay, and this can happen with other kinds of segments as well, as long as they meet on the outside. Here's the trick. The product, we're going to multiply again, of the measures of one secant segment. So let's just focus on one of these segments right here. Move this. I want you to ignore the bottom segment for a second, and we're just going to focus up on the top. Bring this to the front so you can't see the other one. Okay. Just look at the top. The secant segment will be in pink. The segment is the whole thing. Now let's keep reading. Then the product of the measures of one secant segment, that's the pink one, and its external segment. External means outside, the outside piece, the exterior piece of that same segment. So the outside piece is just this little portion right here. So they're saying that you're going to multiply the pink segment times the blue segment. Okay, anytime that you have segments outside. Segments that intersect outside. Okay. Means that there's two pieces involved. There's a whole piece in pink and the exterior piece. So the clue that you want to use is that it's the exterior piece times the whole piece. I'm actually going to write it in parentheses. That'll help you with it later. The exterior piece times the whole piece. That means times. That's the keyword. If you get this part down, the rest will be easier. Now do the bottom one. You have an exterior piece and you have a whole piece. The exterior piece is right here, the part that sticks out from the circle, but the whole piece is the whole segment. So you've got two segments here. The exterior is green, the whole segment is the yellow. So again, it would be the exterior, the green, times the whole thing in yellow. So in our cases here, it would be blue, the exterior piece times what? Look at it. Blue times what? That's right. It would be the pink segment. Blue times pink equals, in our case on the bottom, what's the exterior piece? That's right, it's green. Green times the whole piece. What's the whole piece on the bottom? Yellow. And when we get to examples, I'll show you that in numbers. But just remember, it's the exterior piece times the whole equals the exterior piece times the whole. It's the same on both sides. All right, and the last rule you need to have is if a tangent segment and a secant segment are drawn to a circle from an exterior point. Now stop for a second. Think about the difference between a tangent segment and a secant segment. Do you remember? A tangent segment intersects the circle once. It doesn't go through the circle. A secant segment intersects the circle twice. It goes all the way through the circle. So let's draw that. A tangent line would look like this, or a segment. Then a secant segment would actually go through the circle. If you ever have a case like this, where this segment can be broken into two pieces, but this is really just one segment right there. They have a fancy rule here that you can memorize. If that happens and they meet from the same exterior point, then the tangent segment squared is equal to the product of the measures of the secant segment and its external secant segment. So again, it's the exterior piece times the whole piece. But I'll just show you what they mean. Let's call this X, let's call this A, and let's call this B. All right, they are saying that you could do X squared equals A, the outside piece, times B, the whole piece. It's still the exterior piece times the whole. But look at it. A is the outside, B is the inside, but it's supposed to be the exterior piece times the whole piece. What does the whole blue piece equal? It equals B plus A together. You're not multiplying, you're just adding the two segments together. So A from the outside times B plus A, that represents the whole piece, equals, now look here on the bottom. What's the outside piece, the exterior piece? Just X. X is the only piece that's sticking out there. Exterior times the whole. So the exterior piece is X, but at the exact same time, what is the whole piece? It's just X again. So look, the yellow and the green, the exterior piece, the whole piece are exactly the same. So it really just equals the exterior piece X times the whole piece X. But X times X is X squared. So that's what they're saying up there. That you can square the tangent piece right here, X squared, and you can take the product of the secant, the whole piece, and the exterior piece. What you really need to memorize is that anytime the segments are on the outside, you have outside segments, or segments on the outside, the trick is to remember that it's the exterior piece, whatever's sticking out, times the whole piece. Please Don't fall into the trap of doing A times B. That's not what this rule says. It's the exterior piece times the whole piece. All right, so let's just summarize this quickly here. You don't have any of these examples in front of you, so just look at them. These are intersecting on the inside. So when they're on the inside, you just crisscross. It would be 6 times 5, the two pieces on the same segment, 6 times 5 equals 3 times x. That's it. 6 times 5 equals 3 times x. 6 times 5 is 30, and x equals 10. Okay. This one is different because it's on the outside. Remember, it's the exterior piece times the whole. It's the exterior piece times the whole piece. So let's take one segment at a time. Take the red one. What is the outside? What's the exterior piece here? 6. 6 is the part that's sticking on the outside, so that's exterior. Times the whole thing. Careful. These are two smaller segments. Adding them together, you get a total of x plus 6. The whole red piece is x and 6 put together. So the whole piece is x plus 6. Now take a look at the bottom one, at the green one. Ignore what's on top for a second. And just focus on that green part. What is the exterior piece of that green segment? Just the outside piece. It's 8. So the exterior piece is 8. Look at that green piece. What's the whole piece? 12. 4 plus 8 makes 12. So the whole piece is 12, and now all you have to do is algebra. All you have to do is solve it. But remember, it's the outside piece times the whole green piece. And that's the trick to remember. Distribute 6 times x plus 6 times 6. That makes 36 equals 8 times 12. You can actually go ahead and multiply that. I'll do that to save time right here. So you get 96. Then you have 6x equals 60, because all you're doing is subtracting 36 from both sides. And 6x equals 60, which means that x equals 10. Be careful on some of the homework, they're going to actually ask you to plug it in. This last one, I just want you to get the main idea. It's the exterior piece times the whole piece. And you know, I don't want you to have to memorize more than you need to. There's another formula here, but don't worry about it. Just worry about exterior times the whole. Exterior piece times the whole piece. All right, so in the red one, what's the exterior piece? It's x. X is sticking outside of the circle. What's the whole piece? When you go back to look at the red segment, the whole red segment is x again. So it's just x times x. Okay, here on the green one, or blue, whatever you want to call that, what's the exterior piece that's sticking out of the circle? It's just the 4. This piece right here is on the outside, that 4. What's the whole piece? You got to find the whole entire piece this time. It's 4 and 5 put together gives you 9. So that whole entire piece is 9. It's not 4 times 5. It's the exterior times the whole piece. So now we simplify. X times x is x squared. 4 times 9 is 36. So x equals 6. You could say 6 or negative 6, but you couldn't have a segment that was negative 6. So it wouldn't work. Alright, so in summary, just remember that the segments outside are the exterior times the whole. When the segments are inside, it's each piece multiplied by itself. A times B equals C times D. So you have a few examples on the bottom there. Let's do some of them quickly and some of them we're going to skip. Just remember to be looking for the 4 separate pieces. When they're on the inside, the rule is to crisscross them. And you're going to get really used to seeing that. X times 6 equals 8 times 3. X times 6 equals 8 times 3. x times 6, 8 times 3. When you multiply it, you get 6x equals 24 and x equals 4. For number 2, you have congruent marks here, which makes this 8. But the angle that, or the segments that you're looking for, the segments you're dealing with, are both on the outside. So let's deal with the top one first. You have an exterior piece times the whole piece. Exterior times the whole. That's the key. So we're going to do that on both sides. On this case right here, the exterior piece is 8. 8 is on the outside. The whole thing, though, all the way down is 8 plus 8 makes 16. So it's the outside piece, 8 times 16. The bottom one is still going to be the exterior times the whole. You just have to do it separately. Looking at the bottom one, what is on the outside? The 6 is. This outside piece right here. It's really important to see that we're talking about this piece right here, 6, is on the outside. But the whole piece goes all the way from here to here. And as you put that together, it's 2x plus 6. 2x plus 6. All right, so all you have left is algebra. 8 times 16 comes to 128. That equals distribute. 6 times 2 is 12x, plus 6 times 6 is 36. When you subtract 36 from both sides, you get 92. Equals 12x, and when you divide by 12, it's not going to be a whole number. It's going to be about 7.7. All right, number 3, it's got decimals, but that's okay. You've got one piece that's a tangent and one piece that's a secant. Still want you to focus, anytime it's on the outside, it's just the exterior piece times the whole piece. Do that on both sides. So do that with this segment right here. With this segment, what's the exterior piece? This piece sticking out, 5.2. All right, so we're going to start with that, the outside piece, 5.2. And we're going to multiply that by the whole piece. The whole piece is blue, and you're just adding your segments together. It's really x plus 5.2. Adding them together, x plus 5.2. Now with the other segment over here, I'll do it in green. What's the outside piece? The outside piece is just 7.3. That's what's sticking out of the edge there. But what's the whole piece? Whole piece is also 7.3. That's all it is from beginning to end, 7.3. So it's really squared, it's times itself. So we're going to multiply and distribute 5.2x plus 5.2 times 5.2. Get 27.04 equals 7.3 times itself. 53.29. We're going to subtract 27.04 from both sides. Minus 27.04, and we have 26.25. You can double check the calculations for me, please. And then divided by 5.2. You get about 5. So that's all you do, exterior piece times the whole piece. All right, try as many of those on the bottom as you can, although I'm going to tell you to skip a few because we just don't have time to get into factoring. Try number 4, skip number 5, right skip there. Try number 6 on your own. Number 7, right skip. Number 8, skip it. And number 9, skip it. All right, take a break, and in a minute come back to look at the backside of 11.6. I'll do a few sections with you, but I really want you to be trying some on your own before you get to class to see if you're doing okay with it. All right, that's it for this one. Thank you very much.